Hey students, this is lesson 2.1. We're going to learn how to use inductive reasoning to make conjectures. Go ahead and do the vocab. You can check back with your answers. Okay, one of the things we're going to do is we're going to use inductive reasoning to try and figure out some problems. Inductive reasoning is where you look for a pattern and try and make a prediction from that. So here we are. We have a pattern. We have 4, then 8, then 16, then 32. And there's a couple ways you could look at it. One would be look at the differences and see if you see a pattern in those. And you might notice that we keep adding the last number. So if we follow this pattern, we need to add 32 to 32. That would give us 64. Add 64 to 64, and that would give us 128, and so on. The other way you can look at this is you're just multiplying the last number by 2 always. So there's a constant multiplier here. All right, the next pattern, as I'm looking at this, I notice this one is split up into 4, and then this one is split up into 16 parts. So it seems like each part is being split up into 4 again. So my next one, and I'm going to have to make this a little bigger to get this, I need to have those 16 parts, and then I need to split each of those into 4 parts, like this. And I'm not going to do another one. You get the idea. A couple definitions you need to know. A geometric series is a series that has a constant ratio. So let's just say there is a constant ratio. And an arithmetic series is a series where there's a constant difference. So an example of a geometric series would be this one right here. It has a constant ratio. The ratio is what you get when you divide any number by the previous number. And like 8 divided by 4 is 2. 16 divided by 8 is 2, and so on. That's sometimes called a constant multiplier in that situation. An arithmetic series would be like this next one here, this got a problem here. If you look there, there's a common difference of -4. 40 minus 45 is -4, 35 minus 40 is -4, and so on. There's -5, and so on. So there's a constant add in there, -5. So you need to know those definitions. You need to be able to recognize a geometric series when you see one and an arithmetic series when you see one. Go ahead and do the next problem, and you can check back with your answer. All right, using inductive reasoning here, what conjecture can we make about the 25th term in this? So the pattern is 1, 2, 3, 1, 2, 3, 1, 2, 3. And what we're going to do here is just label this with a term number underneath. This is the first term, second term, third term, fourth term, fifth term, sixth term. And then we're going to try and see if there's a pattern developing here. And one thing you might suspect, since the pattern is 3 numbers, that if you look at the multiples of 3 here, those multiples of 3 will always be 3. That's my conjecture. So if the term number is a multiple of 3, then it'll be the number 3. So I'm just going to write that down, and then I'm going to use that. So multiples of 3 are 3. What I mean by that is the term number. Multiples of 3 are 3. And so let's look at the 25th term here. If we divide that by 3, we get 8 with a remainder of 1, which means that if it was a 24th term, then the number would be 3. Since it's 1 more than that 24th term, it's the next number after 3 in the series, which is 1. So my conjecture is that the 25th term will be 1. All right. I think I'll do this next one in class, and you can try to got it down here. Okay, problem 3, collecting information to make a conjecture. What conjecture can you make about the sum of the first 40 even numbers? Okay, to do this problem, let's look at some smaller examples and collect some information here. So I'm going to make a little table here. Okay, so I'm going to look at the number of even numbers. We're going to start with 1 even number, then 2, then 3, then 4, then 5, and let's go ahead. Think about what the nth even number will look like. Now the sum, if there's one, the first even number would be just 2, because there's only 1, 2. And then the first 2 even numbers, that would be 2 plus 4. That would give us 6. Then 2 plus 4 plus 6, that would give us 12. Then 2 plus 4 plus 6 plus 8, that would give us 20. And 30, and now let's think about what we have going on here. And one thing that I noticed here is that we're adding 4, then we're adding 6, then we're adding 8, then we're adding 10. And the difference between those numbers is going up by a constant. We're always adding 2 more than we added the time before. And if you remember from last year, that means it's quadratic. So we're doing some kind of multiplication here. And one thing that you might notice is this. Think about some numbers that multiply to get 2. That'd be 1 and 2. And then 6, that could be 1 and 6. Or I'm going to lead you here to something else. Think of that as 2 times 3. 12 would be 3 times 4. And I hope you're seeing a pattern here that that we can just multiply the number times the next number. Whatever number of even numbers we're adding times the next number. So in the 5th one we're multiplying 5 times 6 to get 30. So my conjecture for the sum of the first 40 even numbers is we're going to do 40 times 41, and that's going to equal 1,640. Now, you could try that, of course, and just add 2 plus 4 plus 6 plus 8 until you've added 40 even numbers. All right? So that's the idea there. Go ahead and try the got it and see how you do. All right, here we're going to try and make a prediction based on some information. So we're going to try and make pattern out of what's going on here. And it isn't a linear situation or any other kind. But what we might want to do here is just to look at can we estimate how much the cost of the ticket sales is going up. And one way we could do that is just kind of even it all out. We know here we're at about, I don't know, maybe we're at about 25 tickets sold there. And then up here we're at about maybe 425. So we're going from 25 to 425. That's an increase of 400. And that is in 1, 2, 3 months. So it's going up about 400 over the course of 3 months. So we can divide 400 by 3 and just approximate that. That's about, I don't know, let's say maybe about 130, something like that. So if we're just kind of averaging this out, we could maybe predict in February that we might want to add about 130 more to get approximately how many are sold. Now, this isn't really very accurate math, but at least from the pattern, we're getting approximately more. So we can just take 425 plus about 130 and guess that maybe it would be about 555 tickets sold in February. All right, go ahead, you try that. All right, the last thing we're going to do is just show how to use a counterexample to disprove something here. So the first statement says if an animal is green, then it is a frog. And all we need to do is say that, think of some animal that's green that isn't a frog, and then we can show that that isn't true. And I don't know, I know maybe a parrot. A parrot is an animal that's green and is not a frog. For the second statement, any three segments form a triangle, I would say, well, you go ahead and try and make a triangle out of a segment that's 1 foot, another one that's 1 foot, and one that's 1,000 feet long. And the last one says when you multiply a number by 2, the product is divisible by 4. I would say, well, try 3 times 2, which is 6, and divide that by 4. And by showing that that's not a whole number, we're showing that it's not divisible. Go ahead and check your answers on the last problem and do the lesson check to be ready for class tomorrow. See you later.